Okay, so let's talk about coincidences. Sorry, I'm on the wrong slide. Okay, there we go. Coincidences. What's a coincidence? If you want to watch a little Seinfeld quote, a little Seinfeld scene clip that shows you the definition of a coincidence, they do a great job. But a coincidence is defined as a sequence of events that, although accidental, seems to have been planned or arranged. Notice I did a lot of highlighting on although accidental, because the thing that a lot of times we forget is that it is an accident. It just seems to have been planned or arranged. Whenever we're talking about coincidences, we're talking about something that can be explained as a function of just chance. We can actually calculate the probability of certain things happening. Coincidences have a certain probability of occurring. We don't need any other explanation besides the fact that this is a chance occurrence. We have imposed meaning on it. We think it's meaningful, but it really isn't. So, for example, David Myers points out that an event that happens to only 1 in a billion people every day occurs about 6 times a day, 2,000 times a year. And that was back when our population was only 6 billion. So now it's more like 7 times a day. And I can't do the math on how many times a year. 1 in a billion makes it sound like it should never happen. But it does happen several times a day, right? Back when our population was 307 million people, Michael Shermer pointed out that a 1 in a million miracle happens 307 times a day in America alone. So when you say, wow, that's a 1 in a million shot, how could that have happened? It happens all the time. It's just that it's rare. It's really remarkable. 1 in a million miracles statistically should happen 307 times a day in the US. 150 children on average are kidnapped by strangers in the US every year. That's way less common than a miracle, a 1 in a million miracle, right? But what do? We all keep our kids really close. We're scared that the bad guy's going to get them. We're so nervous about things that are really, really unlikely. And then we impose so much meaning on things that are twice as likely to occur, right? Why is that? If you want to have some fun, you can click on this link and find your birth date in pi. Every number, every string of numbers occurs in pi, and it seems so miraculous. It's like, oh, you won't get this one, and then there it is. They may have had to go out a million spaces to find it, but you know how pi goes on forever. It is in there. Any number that you can generate is in pi. I've never been able to come up with something that's not in there. Now, the longer the string that you type in there, the less likely that it is to be repeated. But if you're looking at a birth date, you're looking at a maximum of 8 digits in a row, and the probability of finding that is really high. It's not meaningful, it's just a coincidence. I also have a dowsing video that I like to show. Again, this is from Scientific American Frontiers, and it's called Water, Water Everywhere. And the reason why I like to show it is because this guy who drills wells for a living, takes this big machinery out and actually drills the holes to hit water, said that they send out 2 different kinds of people sometimes to go figure out where the well should be drilled. One type of person is a geophysicist who goes out with special equipment to look for magnetic changes in certain areas that can indicate that there's a crack in the rock and that there's probably water there. Sometimes instead of, or in addition to the geophysicist, they'll send out a dowser. A dowser is oftentimes referred to as a water witch. This is a person who takes like a coat hanger or some other piece of wire, and they walk around with it, and if it moves, then it implies that there's water underneath there. And so there's a guy who is a geophysicist who has now become also a dowser, because he says the times that I mark off the spot using my geophysicist machinery, and then the homeowner says, or the landowner says, wow, that's the exact same spot that my dowser marked. That happened too often to be coincidence. And so I thought, you know what, I got to find out more about this dowsing. And so he decided to become a dowser himself. It's a pretty good video because it shows you how you can actually use scientific methods to test the effectiveness of dowsing. But it's a pretty good example of people saying, oh, that's too coincidental to be ignored. It has to mean something. A lot of times when we see meaning in a coincidence, it's really because we're forming an illusory correlation. We're seeing two things as related when they really are not related to each other. So for example, the gambler's fallacy. Again, I have a great video for you if you want to watch the video that's linked here with the word fallacy. There's a great, what do you call a guy who posts a bunch of stuff on YouTube? Vlogger? Great kid named Charlie Is So Cool Like, who did a little test of the gambler's fallacy, and he really shows that we have expectations that once the die has come up a certain way, a certain number of times, it has to come up something different. Or once the roulette wheel has come up a certain color, or certain, in a string, we start to think it has to come up the other way. In class, I always like to do this little demonstration. I mute the screen so the students can't see it, because of course it's a little bit of a sleight of hand. I tell them, I'm going to flip the coin and you write down what you think it's going to be. And then to ensure that I get what I need it to be, I have this series of flips that I supposedly get. I tell them, I flip the coin and I go, ooh, it's heads. And then I flip the coin, tails, tails, tails on the next 4 flips, right? And what you find is that usually students will have written down no longer than 2 of the same thing in a row as their prediction. So they might go head, tail, tail, head, tail, something like that. They get really close to 50-50. My string of 4 in a row is never what they've written down, because we have this assumption that because it's come up tails twice already, it's much less likely to come up tails again. That's sort of our incorrect belief. It's not actually how the world works, of course. It gives us an illusion of control to think that things are related to each other when they really aren't. That a coincidence isn't just random chance, but that we have some kind of control over outcomes. Now this is a great story because my mentor in graduate school was the statistics professor who taught all of us about probabilities. And he and his wife had 2 sons already when I got down there. And his wife was desperate to try for a girl. She really wanted to go for a 3rd child. And he was lukewarm on the idea, but I think he might have been kind of, warming up to it, because he decided to calculate the probability that given that he already has 2 sons, what is the probability that he would have a daughter? I think I might have I wrote this down incorrectly. But so he's got 2 sons. What's the probability that the 3rd child would be a daughter? He came to the conclusion that it was a 1 in 6 million chance that he'd have another son. So, having calculated out, given 2 sons, what's the probability of a 3rd son? The statistics told him 1 in 6 million. So, of course, he had another baby. What do you think he got? The 1 in 6 million chance? Yes, he did. He got the 1 in 6 million chance. Now, his calculations might have been perfectly fine. Given 2 known outcomes, what's the likelihood that you get the same outcome? But the thing is, for conception, it doesn't know what's come before it. So each conception is an individual 50-50 chance. So he found that out by having yet another son. The reason why he was willing to calculate all this stuff out is it made him feel like he was in control of it. And that way he felt like he could make a more informed decision, because no longer was he leaving it to chance. He'd calculated it out. He had a 1 in 6 million chance that he'd have another boy. That's what we call the illusion of control. Some other illusory correlations that are kind of interesting for psychologists is the just world hypothesis. That's our sort of unconscious assumption that people get what they deserve. Now, we all know that the world's not fair and that randomly bad things can happen to good people and randomly good things can happen to bad people. We all know that, right? But what we tend to do in the just world belief system is we tend to blame victims of random events. I've got a couple of examples. If you click each of those words separately, it's a different video illustrating somebody blaming. Actually, one of them is an actual video. The other one is a list of explanations for why the East Indian tsunami struck where it did. And let's get this to load. You can see I still have Let's Make a Deal up. So on this little website, it's not a video, it's just a list. They're looking at different religions, all sorts of different religions, and their leaders and what they said. Do you guys remember the East tsunami? The East Asian tsunami that came and killed like 150,000 people, right? So they've got Jewish, Christian, Muslims. There's some in here where they have Buddhists and Hindus and Taoism and all sorts of Sikhs who said stuff. God intended the tsunami as a warning. God carefully routed the tsunami to prevent Christian deaths. The tsunami was caused by God's wrath. We got Buddha, Christianity, Hindu, Islam, Judaism. The tsunami is a test from God. God sent the tsunami to punish people because of tourist sexual activities. The tsunami was part of God's plan. Pretty much everybody seemed to agree to that one. These are all examples of blaming the victim of obviously a random event, right? The tsunami was not planned. Nobody had control over that. It's a random event. So, why? All right, let's take a break here and we'll come back in the next segment. We'll talk about why we are so likely to form these illusory correlations.